Welcome to the Introduction to Database Management Systems course. It will cover advanced topics in database such as performance, indexing, algorithms, administration, etc. The course begins with data storage and indexing techniques to facilitate data access. This segment covers the basics of how data is stored on physical media. Within any modern computer, there is a hierarchy of storage based primarily on the speed of access. The fastest storage is that within the processor itself and consists of registers and cache. Next fastest is the main storage, which is often referred to incorrectly as memory or core. It is fast, but also relatively small compared to other types of storage, so its use must be optimized. Next in the hierarchy comes solid-state devices, or SSD, which is most recognizable as USB drives, but increasingly used as a substitute for hard disk. SSD devices are generally larger than main storage in capacity, but slightly slower. Secondary storage or disk comes next and is very large capacity, but much slower to access compared to solid-state devices. Lastly is optical or magnetic tape, which uses removable media and has almost unlimited capacity, but is much slower to access. Secondary storage, consisting of hard and optical disk, has large capacity compared to solid-state devices, but is slow and is mechanical. A disk is some media, usually magnetic or optical, that is spinning and has a mechanical read-write head that moves across the surface, reading and writing the data. Since the disparity in access speeds between main and secondary storage is so great, efficiencies are achieved by reading large blocks of data consisting of multiple records into main storage at once, in hopes that the next record needed is adjacent to the one just read. Selection of the number of records to put into a block based on record size is an optimization to improve overall processing efficiency. Operating systems provide several commands that are used by the database management system to access the records in the file stored on secondary media. Some of the commands allow for a file to be opened, records to be located and then read or written, and finally to close the file. Files are generally organized in one of three ways. The first way is called ordered, such that each record is written to the disk in some known order. The second way is unordered. The records are just written. And lastly is hashed, whereby the location of the record on the disk is determined by a mathematical function whose input parameter is some key from the record. By storing records in a file in a predetermined order, search times can be improved, since a binary search strategy can be employed, which is more efficient than a linear search, which examines each record looking for the desired one. However, ordered files can be more time-consuming to maintain, since inserting records often requires making room for the new record between two existing records. Similarly, deleting records requires closing the gap left by the deleted record. Hashing is a technique that produces a record address by performing a computation on the key of the record. It is very efficient as long as a hashing algorithm produces a unique record location rather than different keys hashing to the same location, which is called a collision. Inserting and deleting records is fairly straightforward. Other searching and sorting data structures and algorithms, such as B-trees, can be applied to ordering files and indexes, which point to records in the file. The use of multiple disks in an array called redundant arrays of independent disks, or RAID, are used to store data used by a database and provide some backup and performance enhancements at a hardware level. Other acronyms for storage used by databases are SANS, NAS, and iSCSI for storage area networks, network attached storage, and Internet Small Computer System Interface, respectively.